Alright, we're going to be talking about equivalent fractions. Let's look at this model right now. This model is showing a whole that is cut into 3 pieces. So if I were to shade in one of those pieces, I would identify this fraction as 1/3. An equivalent fraction is a fraction that looks different but is equal to another fraction, and I'm going to show you how this works. Right now I have it cut into 3 pieces. What if I took it and cut each of those thirds into another piece and just halved those pieces? What fraction does this now represent? Now there are 2 pieces shaded out of a total of 6 pieces. So 1/3 is equivalent to 2/6. They are the same representation of a whole piece. They were just cut up differently. Instead of having just 1 out of 3 pieces, I now have 2 out of 6 pieces. So that is the visual I want you to see as we're talking about how to actually do equivalent fractions. I want you to go ahead and make sure you have that drawn on your teacher side. And then we're going to take a few more notes about equivalent fractions before we actually get into the process. So I do want you to note that equivalent fractions look different but are equal. And when we're talking about equivalent fractions, we're going to have something called the golden rule. You have to remember that whatever you do to the numerator, you must do to the denominator. And we're going to get into a process and you're going to understand what that means. And remember, our numerator is the number on top and our denominator is the number on bottom. The numerator is the pieces we're talking about and the denominator is how many pieces the whole was cut into. And that's some vocabulary that we have discussed in class. In order to do the process for equivalent fractions, there are 2 operations we get to do. So there's an actual process for creating equivalent fractions. We're going to use 2 different operations. The first operation is multiplication, and we're also going to be able to use division. So these are the 2 operations you can use to create equivalent fractions. So multiplication and division can be used to create equivalent fractions. Now let me show you some examples. In our model, I showed you 1/3 shaded, and then I took that 1/3 and divided it into 6 pieces instead of 3 pieces, and then it created 2 that were shaded. These are equivalent fractions because even though they look different, they do represent the same amount of the whole. I'm going to show you how multiplication can be used in this instance to have created this equivalent fraction. And remember the golden rule, whatever you do to the numerator, you must do to the denominator. Well, I'm going to think 1 times 2 equals 2. So whatever I did to the numerator, I must do the denominator. So 3 times 2 is 6. So I can, if I didn't know this, if I didn't have a visual, a model, which models are always good with equivalent fractions, I could just do the process of division. So let's do a few examples on the student side. I'm going to have you do some. I'm going to do a few and then I'm going to have you do some as well. Let's say we had the fraction 1/2 and I want to create an equivalent fraction. I can pick any number I want to multiply the numerator and the denominator by, and I will get an equivalent fraction. So I'm going to pick 4 this time. So I'm going to multiply both the numerator and the denominator by 4. So 1 times 4 equals 4. 2 times 4 equals 8. So 1/2 is equivalent to 4/8. And I could draw a model to show that. If I had half of a pizza and so there's 1/2 right there, but then if I took that same thing and I cut it into 8 pieces instead, you can now see why 4/8 is equal to 1/2 because now there's 4 pieces at a total of 8. Try this one by yourself. I want you to multiply this by 3 to get an equivalent fraction. Go ahead and pause me, try it, and then start me back. When you multiply by 3, 2 times 3 is 6. 3 times 3 is 9. So 2/3 is equivalent to 6/9. I just told you to use 3. You could have used 4. You could have used 2. You could have used 10. I could have said 2/3 times 10, and that would have equaled 20/30ths. But guess what? 2/3, 6/9, and 20/30ths, they're all equivalent. I could take a piece, cut it into thirds, then cut it into ninths, and then keep cutting it into 30ths, and I'm still going to have that same fractional piece represented, even though my pieces are smaller now. Just use multiplication to create equivalent fractions. You can also use division. If you have a large fraction, let's say you have 9/27ths, I can do multiplication, but then I'm going to get a really big number, and it's harder for me to visualize a fraction with big numbers. So I'm going to use division instead. This is where it's really important that you know your divisibility rules. So I'm going to make 9/27ths equivalent to something by the process of division. So I'm going to go ahead and divide by 3 because I know that both 9 and 27 are divisible by 3. Whatever I do to the numerator, I must do to the denominator. So with division, 9 divided by 3 would be 3. 27 divided by 3 would be 9. So 3/9 is equivalent to 9/27ths. 3/9 is easier for me to visualize. I could even break that down even more. I could say, okay, well, I know that 3 is divisible by 3, 9 is divisible by 3, so my new equivalent fraction would be 1/3. 1/3 is easy for me to visualize. It's one of our common fractions, and people have an easier time seeing 1/3 than they do 3/9, and especially 9/27ths. Alright, so let's try another one. Say I have 3/18ths. What do you think we're going to divide the numerator and the denominator by? Well, this is where your factors come in too. The only factors of 3 are 3 and 1. You're never going to divide by 1 because 1 is not prime or composite. You always want to divide by either a prime or composite number. So 3, we'll do it divisible. It's divisible by 3 because we just said the factors of 3 are 1 and 3. So whatever we do the numerator must do the denominator. 3 divided by 3 is 1. 18 divided by 3 is 6. So 3/18ths is equivalent to 1/6. 1/6 is a much easier fraction to be able to visualize and to model. Say we had 6/8. We had something cut up into 6/8. I want to find an equivalent fraction to 6/8. I want you to divide by 2. 2 is actually the only thing you could divide this one by because 6, even though 3 goes into it, 3 will not go into 8. So if it doesn't work where it can go into both of those evenly, you can't divide by it. So had somebody tried to do 6/8 divided by 3, they would have said, okay, well 3 goes into 6 2 times, but 3 does not go into 8, so you cannot make an equivalent fraction that way. So you have to use something that will go into both numbers evenly. So go ahead and try this. Alright, 6 divided by 2 is 3, and 8 divided by 2 is 4. So your equivalent fraction is 3/4.